two different machines for two different purposes, two different objectives. This is very generic in nature. This is very, very specific. The art and the beauty and the real magic will happen if we are able to use these simple commodity technologies to bring intelligence very closer to complement human beings. Most people who show me various kind of robots using commodity technologies, one of the most fundamental mistakes they do, they take generic AI objects and use their APIs or use their narratives or use their construct to create something which is highly customized for their industry, and they gloriously fail in that. And the reason why they fail in that, because of this remarkable mistake of saying that I'm going to use something which is very generic in nature to solve a particular problem which is very, very specific in nature. Now we are going to demonstrate that, and I hope a lot of people will get encouraged after seeing that demonstration that they can build beautiful, cheap, intelligent machines by writing custom code, by creating custom neural network of your own, by creating custom design, and by creating custom components. And how do you bring them together? If you want to seek answers or seek information which is very generic in nature, where is my house, how much time it takes me to reach a particular destination, how far is this particular place, which is the best hotel, how much distance I have to travel to reach this particular destination. They are very generic in nature. For that you have Alexas of the world, you have Siris of the world, and they will give you intelligent answers because they have been trained by the sheer usage, and they are very, very accurate or nearly accurate. But if you have to train a machine or build a machine to solve a specific problem, and let's take an example of a specific problem. Somebody has to basically create a machine, a robot, which will ensure that a right patient is treated by a right doctor at right time with right diagnostics at a right price. And if you try to use generic algorithms or generic machines, we will demonstrate to you that you may be doing a huge mistake, and their Alexas of the world or Siris of the world fail. And there you have to write your own cognitive algorithms, you have to build your own machines, you have to train your own machines, and you have to really write custom code. And that custom code is useful not only in terms of solving that particular problem, but also connecting it with an external ecosystem of your own domain, which are other systems, which are other behaviors, which are regulatory agencies, and so on and so forth. The point which I'm trying to make is, if you have to create meaningful machines, then those meaningful machines have to live in an ecosystem which already exists. Nobody is going to create a separate ecosystem for a machine just because we have built it or somebody else has built it. We have two beautiful machines in front of us. One is great Alexa, built by a great company, great tech platform. Another is our custom, cheap but beautiful robot. Both of them neural network, both of them are intelligent machines, both of them have used similar technology in very different way. Both of them have very different use cases. Now the idea is not to compare these two different machines because they are entirely two different machines for entirely different purpose. Now while we were constructing this particular robot, we actually went through a test, and that test was conducted through people of different age, different demographics, different languages, different thinking. And we actually came across a large data set where we understood that generic machines will fail to solve specific problems. This is a particular machine which is there to cater needs of customers from a perspective of aviation, from a perspective of airport and airlines. This is a machine which is built for generic use, for citizens, for general population, for everyone. Both of them have commonality in terms of neural, commonality in terms of NLP, and commonality in terms of data set from an architecture perspective. How you use them and how they respond is something very interesting. So I'm going to go through a set of questions starting with Alexa and how remarkably Alexa attempts to answer these questions, but quite differently than what this particular machine does. So let's start. Alexa, what are the advantages of lithium-ion battery?
Lithium-ion battery is usually defined as a type of rechargeable battery used in many consumer electronics devices.
Alexa, what is the Digital India program?
Here's something I found from the article Ravi Shankar Prasad on Wikipedia. Ravi Shankar Prasad is spearheading the Digital India program as Minister for Electronics and Information Technology since May 2014.
Alexa, what is the king of fruit in India?
Sorry, I don't know that.
Alexa, how can I increase my calcium?
Sorry, I don't know that one.
Alexa, can you repair my laptop?
Sorry, I'm not sure.
Now, if you actually look at how interesting it is, questions which are very, very generic in nature, mostly which are not country specific, Alexa should be able to answer that. But when they become very specific, when they become very task oriented, when they become very activity oriented, when they become very, very domain oriented, Alexa struggles. That doesn't mean that Alexa platform is not a great platform. Actually, it's a beautiful platform. That just means that demystification of robotics, demystification of artificial intelligence is extremely, extremely necessary. That clarity of thought and design should be very, very clear in the creator's or engineer's mind when they want to create the machine. Now, let me just ask some of the generic questions and you will see how remarkably and beautifully Alexa answers. Alexa, what is the weather of Delhi?
Currently, in Delhi, India, it's 37 degrees Celsius with partly cloudy skies. Tonight, you can expect haze with a low of 28 degrees.
Alexa, sing Twinkle Twinkle Little Star for me.
I think you're asking for the song Twinkle Twinkle Little Star. Is that correct?
Yes.
Twinkle Twinkle Little Star from Savani.
Alexa,
Sorry.
stop. The point which I'm trying to make is quite clear. When you ask generic questions which has been asked by several people, which is there in the public domain, which resides on a huge platform or ecosystem of internet, Alexa is quite accurate. It is able to converse. It doesn't struggles because that's how it is tuned. So whenever you want to use Alexa APIs in the context of a domain, be very careful how you are going to put your parameters and whether those parameters will fit or not, because your learning cost and your learning time can be enormously high. So that's one lesson which everyone should understand, that when and where to use generic machines and how to use those generic machines in the context of a custom problem or a custom domain. Now let's ask a very, very cognitive question. It's a beautiful question, don't take it in a different way. Alexa, are you my friend?
Sure, I'm always happy to make friends.
Now that's a great answer. Alexa, will you marry me?
I think that would somehow violate the laws of robotics.
Now, this is another area where I want to touch, where the differentiation between machines and humans start to appear. I'm not going to get into a topic of humanoids or something like that because that's a very, very different topic. But I just wanted for people who want to understand a difference between generic machines, generic intelligent machines versus problem solver intelligent machines. They should be very, very cautious of the fact that they should keep humanoids and the exterior part of humanoids separate from intelligence, because exterior part of humanoid is expensive but not impossible to build. The intelligence which comes closer to human intelligence is not only expensive but today a little bit impossible task for computer science engineers. That's the third point which I wanted to make. We are going to ask same set of questions which we asked Alexa to this reasonably domain-specific tuned machine with a custom AI algorithm, both in case of supervised learning and unsupervised learning. How can I increase my calcium?
Foods which are rich in calcium. 1. Dairy. Obviously it's the most calcium-rich and easily available food on earth. Milk, curd, cheese, etc. 2. Sesame seeds. 3.
Can you repair my laptop?
I think what you're asking is how can you post on Instagram from a laptop view? To schedule and automatically repeat your posts on Facebook, Twitter, Pinterest.
Can you repair my laptop?
Yes, it is possible, but again depends on kind of repair we are attempting.
What is the king of fruit in India?
Mango is called the king of fruits. First of all, mangoes taste so good that people.
What is Digital India program?
What is Digital India? The Digital India initiative seeks to lay emphasis on governance and transform India into a digitally empowered society. The program is.
What is logistic blockchain? How to apply for a passport in India? How to apply for passport in India?
One. Create a new account in passport website. 2. Fill the online application form. 3. Pay and schedule for an appointment at your nearest PSK Passport Seva Kendra.
If you actually look at these set of questions, they were similar in nature. Two different machines for two different purposes, two different objectives. This is very generic in nature. This is very, very specific. So if you ask this particular machine questions like, hey, where I am exactly at airport, where is my gate, what is written on my boarding card, where is the lounge, where is this particular gate, is my flight on time, what is the weather of my destination, can I get surrounding information of my arrival, destination, blah blah blah, and it will give you accurate answer. If you ask this particular machine where is this particular coordinate, whether it is airport, whether it's temple, whether this is building or something like that, it will give you a reasonable answer. If you ask this particular question saying that, hey, sing a twinkle twinkle little star to me, Alexa will actually give you a very, very accurate answer. Both these machines struggle the moment you basically get into depth. And when I say depth, it means subject depth. When you become specific, there are various reasons for it. One of the reasons is that, are these machines learned? Are these machines trained? Who trains these machines? Information trains this particular machine. Algorithms trains this machine. How do you train these machines? You train this machine by creating large data sets and writing algorithms and making sure that these algorithms get improved based upon certain decisions which are cognitive decisions. Now, the reason why they struggled were similar but different from a design perspective. This machine struggled because algorithm is not that evolved. This machine struggled because it has not learned, it has not been trained to hit that particular data set, even though it exists on internet, but usually people are very specific. How many people really ask these questions like, tell me specific of blockchain or something like that. Another remarkable thing which you have noticed, while Alexa was pretty much consistent, this machine was learning, and that's how you write algorithms. When you are trying to solve a particular problem of a particular domain, you basically write algorithms which are self-learning in nature, and that's where the combination of learning and self-learning or forced learning appears. It's a choice which you make. It's a risky choice. If you are okay in terms of creating two parts of the particular machine, one is pretty much a forced learning in the sense that, oh, I know what kind of questions will be there for this particular domain, which I've explained in the context of airline, and then take a risk saying that, hey, anyone can come and ask any kind of questions. You have to fundamentally separate two different algorithms, two different coding styles, two different design styles, two different tech stack, but your machine remains same. Alexa, I speak at Alexa here, the mic is over here. That's the ergonomics of machines, which also play a very, very important role. A lot of people pay a lot of emphasis on NLP. NLP can take you to a particular point, but after a particular point, the design really matters. where do your machine hears, what it does with those tokens which comes as sound, how does it convert those particular tokens into sentences, how does it narrate those particular sentences into a set of answers, and how does those answers translates into intent, which I have not touched. So idea was not to compare or do a direct comparison, but idea was to give emphasis that if you take a generic machine to a specific zone, if you basically take a depth, a specific machine to a little bit higher domain-oriented zone or in a generic cognitive environment, they struggle, like humans struggle when you take them out of a comfort zone. That kind of agility and that kind of flexibility in terms of intelligence is something to look forward and exciting in the commodity zone of technology. It exists in a specialized zone, but it's very expensive. The art and the beauty and the real magic will happen if we are able to use this simple commodity technology to bring intelligence very closer to complement human beings, and that was the whole idea.